Hi there, it's Mrs. Nelson. Welcome to kind of another lesson in current. Today we're going to talk a little bit about electric current and voltage, and we're actually going to do a little bit of math. I know that scares some of you, but please just bear with me. I'm going to make it as painless as possible. If you have questions, make sure you contact me. I just want to quick note that I did kind of on the unit plan and lesson overview that I included in your paper packages, I made a bit of a typo. So I have corrected it. Today I had notes on resistance. I had missed out these notes on electric current and voltage. So I have put the voltage notes back into today. So we're going to do pages 9, 10, and 11, and maybe the top of page 12 today, and the top of page 12. So we're going to do pages 9 to 12 today, and then we'll flip to those resistance notes tomorrow. So just make sure you fix that in your package and follow along. So again, we're on page 9, so we're going to talk a little bit about what electric current is. So the movement of charge, or the movement of those electrons, is called current. Current is described as the amount of charge that passes a point in a wire in a certain time period. So an instrument that measures current is called an ammeter. So current is the word we use, but when we're putting this in a mathematical equation, we actually need a symbol. So the symbol we use for current is I. So this is where it gets a little tricky. The symbol for current is I, and I just updated my notes here because the font I had used, I hadn't actually had an I that has kind of the horizontal cross top and bottom, and it makes a lot more sense. So that's all I've added in there. And current is measured in a unit called amperes, or you may have heard of it shortened called amps, and the symbol for amps is A. So current is equal to Q, which is our charge, and charge is measured in coulombs, divided by our time. And in this equation, time is always measured in seconds. So I want you to kind of fill in those notes and then fill in this equation. So again, current is I, that's the symbol for the word current. It's measured in a unit called amperes, A. Charge is Q, so charge moving past a point, the symbol for that is Q, and it's measured in a unit called coulombs, which is a capital C. And T here is time, and time is measured in seconds. You do, if you've looked through your paper package, you do have a formula sheet, and all of these are outlined just in that way. So I'm going to talk to you a little bit about how to use that in a second. So on your pink formula sheet that was included in your paper package, you have what's called a math triangle. Math teachers like to call it a science triangle. But basically, this triangle that you see here is a way that we can help to rearrange those formulas without doing a lot of math. Okay, so I'm going to just uncover this red. So this red box here, if I'm trying to solve for current, which is I, I'm going to cover up the I. Then I'm left with Q on the top and T on the bottom. So Q over T, and that over line is divided by, just like I've got here. So again, if we look up here, I is equal to Q divided by T, or if you like it like, Q with the division sign, although I'm going to always use the line Q over T. Again, how do you know what you have from your problem? You might have to match up your units. So if if it says something's got so many coulombs of charge and something's got measured in time, then you'd have to say, oh, if it says, 8C and 10S, then I have to match up my units. So this is going to be a little bit tricky for me to teach you because it's harder for me to see where you're going wrong, and maybe a little harder for you to learn what we do online. So I encourage you to ask questions where we can. Okay, so if my problem gives me, gives me Q. It says the current is such and such, the time is such and such, what's the charge? I'm going to cover up Q, and I have a little square that I can move around. You just use your thumb. And I and T are beside each other. So if they're beside each other in this triangle, that's going to be multiplication. So Q is going to equal I, current, times time. And if they say, oh, this is the charge and this is the current, how long would it take? What's the time it takes? Then I cover up T because I'm trying to find for that how long. And I'm left with Q again over, and that over line is divided by I, Q over I. So just make sure that when you're doing your formula and you're plugging in your values, that you're solving and using the steps. So I've included the steps in your notes here. I've also included a white sheet in your paper package that has all those steps written out for you. So again, here's just the notes on how to use a math triangle. Cover up what you're trying to find. So match up your symbols, multiply if they're side by side, divide if they're top and bottom. Big thing with the division is if Q's on the top, that's always the number that whatever number is Q, whatever's got coulombs as a unit, is going to be on the top, not always the bigger number. So having a current of 1 amp or 1 amp here means that 1 coulomb of charge is moving past a point in the circuit every 1 second. So a coulomb of charge is equal to 6.25 times 10 to the 18 electrons. So some of you will have done scientific notation and math, some of you won't, but this 6.25 is times 10 times 10 times 10 times 10, 18 times. What I can do is I can move this decimal place over 18 times. So a coulomb of charge is equal to this many electrons moving past a point every second. So that's a lot of electrons. So bottom of page 9, we're going to do an example now. And I would really encourage you to write out all your steps. That's why I went to the trouble of including these steps on a white sheet of paper in your package. So you can always, as you're doing the problems, you've got this beside you and you're following the steps. So for example, if 240 coulombs of charge, 240 coulombs, okay? It also says charge, but we also might know just from looking at it that charge, 240 coulombs, if I look at my pink formula sheet, coulombs measures up with that Q. Passes a point in a conductor in 5 minutes. So 5 minutes is a measure of time, but our time must be in seconds. And so to help you out a little bit, I did put 300 seconds behind it. 5 minutes, obviously, we know, we can kind of understand how long 5 minutes is. 300 seconds loses its meaning a little bit. We could convert this just by timesing 5 times 60 to get the number of seconds, but I've given that to you to, again, reduce that bit of math you have to do. So what's the current? So what is the current? Well, we don't know. So we don't know what I is, but I is what we're trying to find. So if you're kind of do what I did and kind of write those symbols above, as you read through the question, it makes it really easy to answer. So first thing, step 1. Write down what we know. Well, from the question, I know that Q is 240, T is 300 seconds, and what's I? I don't know, question mark. I equals question mark. So I've written down exactly what I know. So you should be filling this in step 9 at the bottom of page 9. Determine and write the formula. So again, here's my triangle, and again, this is what I find on my sheet. I'm going to cover up, and I don't really have anything to cover it up, so I'll just cover it up with my pen, cover up I with my finger, and I'm left with Q over T, or Q divided by T. So I'm going to determine the formula and write it down. And again, when I'm determining that formula, I should be solving for whatever has the question mark beside it. I'm going to put in my known values because I've written everything down here. I know that Q 240 is going to go on the top and 300 is going to go on the bottom. So, oops, sorry. I is going to be, oh, it's not happy, that's for sure. All right, Smart Notebook, come on, don't fail me now. All right, so it's not happy, so maybe we'll do this the old-fashioned way, scroll it down a little bit, at least we'll get to the bottom. So we sub in our values and we solve. So current, I, is equal to 240 divided by 300. So I use my calculator, 240 divided by 300. Again, you'll notice it's not just the bigger number that goes on the top. I have to match up what I wrote down as my known into my formula. It equals 0.8. That can be the end of the question, but I need to write my answer. I need to write in the units in this case, and I should be putting a box around it saying that's my final answer. So I is equal to 0.8 amps. Okay. I would encourage you to pause the video here and try the questions on page 13 and 14, 1 to 4. So if I was you, I would pause those and practice those ones. I'm going to make this one big long video though, so we're going to pop on page 10 onto potential difference. So potential difference is the movement of electrons in a circuit due to their attraction to the positive terminal, the positive end, and the repulsion of the negative charges to the negative end. To affect electrons, the positive and negative charges must be separated and held apart. So in a battery, if you have ever looked at a battery, just like a double A or a C or D cell battery, you'll notice that one side of it has that kind of nub, and that's the positive end, and the other side, if you look at it, has a negative end. So in that battery, we've separated the positive and negative charges. That's the chemical energy. So we have to put in work and energy in order to separate those charges. So in a battery, a chemical reaction, again, my smart notebook's not happy, inside a battery separates negative and positive charges and keeps them apart. Similar to the stretching of an elastic band. Work or energy has to be added to that elastic band to stretch it out. As you hold that stretched band, it's called potential energy. There's potential energy stored in that band. If you were to release the elastic band, that energy is released. It's turned into what we call kinetic or moving energy. So the storage energy, that potential energy from the stretching, is released as movement or kinetic energy. Electrons are held at the negative terminal, the negative end of the battery. Electrical energy is stored. It's called electric potential energy. If allowed to come together by closing a circuit, the electrons will move to the positive end. All forms of energy are measured in joules. That's a capital J. And again, I picked a kind of a poor font. That should kind of have a J at the top there. Electric potential or potential difference or voltage. So electric potential energy, potential difference, and voltage at this level are all about, mean about the same thing. There's some slight differences that you'll learn about if you take physics 11 and 12. So potential difference or voltage is capital V, and it's described as potential difference at V is equal to E divided by Q. So E stands for energy, it's measured in joules. Charge is still Q, it's measured in coulombs still. So voltage, electric potential, potential difference are all measured in volts. Energy is measured in joules, charge is still measured in coulombs. Same thing, there we are. So potential difference is the same as electric potential, which is the same as voltage. So those words all mean the same thing. So in this case, you're going to be looking for that symbol, that V, because they might use the same thing. You can measure that potential difference between 2 points in a circuit with an instrument called a voltmeter. So again, here's our math triangle, okay? So if we're trying to solve for V, we cover it up with our thumb. We're left with E divided by Q. Okay, if we're trying to solve for Q, we cover it up. We're left with E divided by V. And if we're trying to solve for E, cover it up. And V and Q are beside each other, so we would multiply. So again, cover up what you're trying to find. Match your symbols up, right? So if your question's asking you about volts or charge or coulombs, you have to match those symbols up with your formula sheet. If you cover up what you're trying to find and what's left are side by side, you're going to multiply. If what's left are, top and bottom, you're going to divide. Again, making sure whatever's on the top stays on the top. So, for example, in a battery, 45 joules. So joules is a measure of energy if we read farther. So 45 joules of, here's one of my symbols. I need to match that up. It's going to be energy. Are converted into electric energy by separating positive and negative charges. This energy places 15 coulombs. Okay, so there's my second number and unit. So if I look up C, I'll notice that it's a measure of charge, and the symbol for charge is Q. What's the potential difference? What is it? V? I don't know. Oops, sorry. A little bit hard. We don't know what V is. But if you read the question and try to match it up, there's no reason why people can't do some of this. Okay, but again, you can't just shut down because I said the word some math. You just have to read and hopefully try to solve problems and ask questions if you need a hand. So step one, write down what we know. Well, we know that E is 45 joules. We know that Q is 15 coulombs. And we know we're trying to solve for V. So again, covering up V, E divided by Q. So V is going to equal E over Q. And this is my preference for how you write it. I know some of you are going to want to write it this way, and that's okay. But I will never write it that way, so you should probably get used to writing it in that circle. So in this case, E here, so I'm going to sub it in there. So E is going to be 45, and Q is 15. So again, I'm going to sub that into the bottom there. I'm just going to go there. V is going to be 45 divided by 15. I type that in my calculator if I can't do it in my head, and I solve it, and I get 3. Last step, and you can do it here if you want to kind of save yourself some writing. Can I write my answer, add in my units, and put a box around it like that? Sure can. But the idea is that voltage is equal to 3 volts. Okay, so we've learned 2 different formulas. So hopefully you did pause and do page 13 and 14, the electrical current problems. What I'd like you to do now, so make sure you've done pages 13 and 14. 13 and 14. So 13, 1 to 4. Those are on the first bit, that electrical current. So you're just going to use that first formula we used for 13, 1 to 4. You're just going to use that formula. That's I is equal to, doesn't want to let me do my pen here. I is equal to Q over T, and whatever formulas that you can get from there. Then you're going to work on page, once you're done that, you're going to practice potential difference. So that's page 14. Numbers 1 to 3. And on those ones, that's going to be that voltage potential difference. And you're going to use that other formula, which is V is equal to E over Q, or whatever you can kind of solve to rearrange there. So that's what you're going to do today. And then I'm going to flip those mixed up problems on page 15 and 16 into tomorrow as well. I hope that's helpful.